and today we're going to learn the chapter of quadratic equations. So before we understand quadratic equations, let us first understand what a polynomial is. We'll start with the very basics. So let us assume a function f of x which is equal to a n x raised to the power n plus a n minus 1 x raised to the power n minus 1 plus a n minus 2 x raised to the power n minus 2, and it goes on till a square x square plus a1 x plus a naught, where a n is not equal to 0 and a naught, a1, a2 till a n, all of these belong to real numbers. Now this entire expression is known as a polynomial. Okay. Now these numbers a0, a1, a2, a3, a4 until an, these are known as your coefficients. Coefficients of these terms. Okay. This is a polynomial in x, where x is your variable. Fine. Now the term, now let us define another thing. Okay. So when you equate this entire expression equal to 0, it becomes an equation. So right now, before equating it to 0, this was a polynomial, and now when you equate it to 0, it becomes an equation. Okay. Now there is a term where n is mostly a natural number, it can also be a rational number, real number. Okay, that's fine. Now the term, I'll define another term, degree. So what is a degree? The term with the highest power of the entire expression or the entire polynomial is known as your degree term. Okay, but in this case we have n minus 1, where I have the powers of x as n minus 1, n minus 2, x square, x raised to the power 1 and x raised to the power 0. Okay. In this entire expression we have this term a n x raised to the power n. This term is your degree term, and n, which is the highest power, it is known as your degree term. Degree of the polynomial. So degree of the polynomial in this case is equal to n. And in this a n x raised to the power n, this a n is known as your leading coefficient. Leading coefficient is basically the coefficient of the term or coefficient of the degree term which has the highest power. It's fine. Now another property of polynomials is that when you basically bifurcate the polynomial into smaller terms, all of the resulting expressions are also polynomials in themselves. For example, if we take just this term a0, so let us assume another function px is equal to a0. This is also a polynomial. If we take these two terms a1x plus a0, this is also another polynomial. Let us take this as p1x. So a1x plus a0. Okay. This term which does not have an x, this expression which does not have an x term, this is known as a constant polynomial or a constant function, you can call it. And this term, this is known as a linear polynomial, where the power of x, maximum power of x is 1. Okay. If we take these three terms, p2x is equal to a square x square plus a1x plus a0. This is your quadratic polynomial. Okay, where the maximum power of x is equal to 2, and in this case a2 will not be equal to 0, and a2, a1 and a0 obviously belong to real numbers. Okay. So let me just erase this before I start. Uh, Let us now start with zeros of a polynomial. So if we have f of x as, let's say, a1x, a0 plus a2x square plus term. So in this case, whatever values of x which make this entire expression is equal to 0, those values of x are known as the zeros of the polynomial. Let me just write this. Those values of x for which f of x is equal to 0 are known as the zeros of the polynomial. Fine. Let's take an example. Let's say we have f of x is equal to x square plus 3x plus 2. Okay. Let us take the value of x as 1. So we have f of 1 is equal to, say, x square minus 3x plus 2. So we have x is equal to 1. So f of 1 will have 1 minus 3 plus 2, which is equal to 0. Let us take another value, f of 2. 4 minus 6 plus 2, which is also equal to 0. So these two values, 1 and 2, x is equal to 1 and x is equal to 2. These two values are the zeros of this expression or this polynomial. Okay? Now, a polynomial has a property that whatever is the degree of the polynomial, it will have those many number of roots, those many number of roots, or you can call them zeros. Here, so if the degree of a polynomial, in this case, let's say n, we have an x square is equal to 0. Okay? So in this case, the degree of the polynomial is x, and the maximum number of roots it can have is equal to n. Roots or zeros are, for now, same thing. Okay? So the maximum number of zeros in this case will be equal to n. We have a quadratic equation written over here, x square minus 3x plus 2. We saw that it has two zeros exactly, x is equal to 1 and x is equal to 2. If you have another cubic expression, x cube plus something something something, so it will have three zeros. If you have a linear expression, let's say for example f of x is equal to x minus 1, so this will have only one zero, that is equal to x is equal to 1. You will not find any other value of x in this case for which this entire expression will be equal to 0. For only one value of x, this entire expression will be equal to 0, and that is your zero of the polynomial. Okay? So this we can write this down if you want, that a polynomial will have at max zeros, which is the at max those number of zeros which is the degree of the polynomial. I hope you understood all of this. Okay? So let's move on further. Now let us start with the types of polynomial. Now we are going to classify types of polynomials into two types based on two categories. First is based on the degree, and the second is based on the number of terms. Okay? Based on degree. First, in this case, we have is a constant polynomial. Constant. Can anyone try to guess what is the degree of a constant polynomial? If you're thinking it's going to be 0, I'll let you know later, but for now, I'll just tell you the degree of a constant polynomial is not defined. It's undefined. Okay? I'll let you know later why this is so and not 0. Second case is for linear. For linear, we have example as f of x is equal to ax plus b. You can take the constant example as f of x is equal to c. C is a constant, and in this case, in the linear expression, as I already told you, the degree is equal to 1. Next one is quadratic. Quadratic general equation can be write as ax square plus bx plus c. In this case, the degree is equal to 2. Okay, because the highest power is 2. Next case is cubic. Although J doesn't move beyond quadratic, cubic and biquadratic, but it's better if you know this. F of x is equal to ax cube plus bx square plus cx plus d. This is a general expression for a cubic polynomial, and in this case the degree is equal to 3. Next is biquadratic. So in the case of biquadratic, you have f of x is equal to ax raised to the power 4 plus bx cube plus cx square plus dx plus e, and here in this case the degree will be equal to 4 because the highest power in this entire expression is equal to 4. Okay, and although this ज़्यादा नहीं जाएगा, but you should know that when the degree is equal to 5, it is known as a quantic polynomial. Fine. This is more than enough for this, and based on the number of terms. First in this case is a monomial. Very obvious from this, the term mono is there, mono means 1. So the number of terms in this expression will be equal to 1. That is f of x is equal to x, 3x, root 3x or anything like this. There's only going to be one term. Second is, in this category is a binomial. Binomial, bi means 2 and nomial means terms. Okay. F of x is equal to, let's say, x plus 3 or 3x plus 3 or something like that. Okay, there are going to be two terms. One is 3x and one is equal to 3. Now let me ask you a question. For example, if I have x plus root 2x, is this monomial or binomial? Take a guess. I'll give you time. So let me tell you, you can always take x common and write this as 1 plus root 2. Now there is only one term and therefore this is a monomial as opposed to a binomial. This is not a binomial, but this is a monomial. Okay? This is just a general idea of type of polynomials. So I hope you understood all of this. If you have any doubts, you can ask me, and we'll move on further. Let us start with quadratic equation policy. So any expression f of x which is equal to ax square plus bx plus c, this entire expression is known as the general expression of a quadratic equation where a is not equal to 0 and a comma b comma c they all belong to real numbers. ठीक है, so this is a general expression of a quadratic equation where degree is equal to 2 and you can always have this इसके अंदर the maximum number of roots is equal to 2. Okay, now if you want to find the zeros of this polynomial ax square plus bx plus c is equal to 0. ठीक है, we want to find the zeros or the roots of this equation. So let us assume two roots alpha and beta. ठीक है, these are the general terms used when we use roots of the equation. ठीक है, so there are three methods of finding the roots of the equation. That is now methods of finding roots of quadratic equation. ठीक है, the first one is splitting the middle term. Second one is making perfect square, and the third one is your Sridharacharya formula. Okay, I hope you understood all of this, and I'm going to start with the middle, splitting the middle term. Okay, so I think most of you are aware of this method already because you have studied in your lower classes. So let us assume a quadratic equation x square plus 3x plus 2. Now I'll just tell you in brief, even if someone doesn't know, so they'll have an idea. Okay, so what you do in splitting the middle term, you take the term which contains x. Now what you have to do is split this term in such a way that the coefficient turns out to be a product of this. Okay? For example, if I write this as x square plus 2x plus x plus 2 is equal to 0. Okay? Now I have split this 3x into 2x and x. Now 2 and this is basically 1x. 2 and 1 multiplied, it gives me 2. Now after splitting these two terms, you need to have such terms that which give you the product of this the constant term, which give you the product as this constant term. Okay, 2 into 1 is equal to 2. So now further what you can do is take x common from this, like x plus 2 plus you can take 1 common and x plus 2. Now from both of these you can take x plus 1 common and x plus 2 is equal to 0, which gives you x is equal to. Now product of these two quantities is equal to 0, x plus 1 and x plus 2, which means either of them can be 0, that is x is equal to minus 1 or x is equal to minus 2. These two are the roots of your quadratic equation f of x. Okay? This is your basic splitting the middle term. Now I'll tell you about making perfect squares. So let me just erase this. Students generally find making a perfect square sometimes a little difficult, although it is not very difficult. Ax square plus bx plus c. I have assumed the general expression ax square plus bx plus c is equal to 0. Now I have to find the roots of this equation. I have to make this a perfect square. Okay. So what I do, I'll tell you a general trick for this. Let us see x square plus. The first step in making a perfect square is to you have to make the coefficient, the leading coefficient, the coefficient of x square, that is equal to 1. Okay. So it becomes x square plus b by x plus c by is equal to 0. What I have done is I have divided both sides by a, so that this term becomes 1 it becomes b by a, this becomes c by a is equal to 0. Now, what my second step is going to be, I'll take this b by a. Now I know I have to split this into, for making it a perfect square, I just divide this term by 2. So if I divide this term b by a by 2, I will get b by 2a. Take it. So now my entire expression I just write in a simple term, x plus b by 2a raised to the power of 2 minus b by 2a whole square plus c by a. So what I have done is basically taken this x plus, when I divided this by 2, it becomes b by 2a. Now I have taken this b by 2a as plus in this expression, this whole square. This, and I have subtracted the square of this, okay? Minus b by 2a the whole square and c by a as it is come down. Okay? This expression is equal to 0. Now you have created a perfect square in this. Okay? If you want to open this, वही आने वाला है. So basically general idea is that in any a plus b whole square, when you open this, a square plus 2 times a into b plus b square. So basically what I have done is I have taken this and added an extra 2 from my side. So this becomes x square plus 2 times b by 2a times x plus b by 2a raised to the power whole square. Okay. I have added this term since this term was already not there. X square was there and b by a I have written this in this format. Okay. 2 times b by 2ax plus b square by 2a the square. So I have to subtract this term as well since I have added this b by 2a whole square and c by a comes as it is. C by a is equal to 0. Okay. Now all first 3 terms in this, they are going to become basically x square plus twice of something times x plus the whole square. Okay. So this term becomes x plus b by 2a the whole square. And you have minus times b by 2a square plus c by a is equal to 0. And this is what we achieved already. Okay? The simple technique of doing this is बीच वाले term को, for the middle term you just divide this by 2 and write this in place of x plus b by 2a whole square minus the square of this term and take the constant term as it is. So you have x plus b by 2a whole square minus b square, and if you open this, x plus b by 2a whole square is minus, you have b square by 4a square, and if you try to add this directly to get LCM, 4a, so 4ac, I'll just oh yeah, we have minus b square plus 4ac upon 4a square is equal to 0. Let's enter this side, x plus b by 2a whole square is equal to b square minus 4ac upon 4a square. Now we just take root, x plus b by 2a is equal to under root of b square minus 4ac upon 2a, and since this is going to be modulus, so therefore x is equal to minus b by 2a plus minus b square minus 4ac whole upon 2a. Okay. This is the way you can find zeros of a quadratic equation by making perfect square. Okay? I hope you understood this method. Understanding the proper procedure is more important in this one rather than finding the solutions, because other formulas of other methods of finding the roots are more convenient. इसमें समझ में आना चाहिए ज़्यादा important. ठीक है? So I hope you understood this. I'm going to remove this. Let's start with the third method, that is the Sridharacharya formula. I think you already studied this in your lower classes, very easy to figure. So whenever you have an expression, quadratic expression as ax square plus bx plus c is equal to 0, the roots of this expression are equal to x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. We derived this expression from making the perfect square method. Okay? These are going to be the roots of this equation. Where one root will take as alpha and another root has taken as beta. Okay? Two roots are going to be minus b plus b square minus 4ac upon 2a, and the second root is going to be minus b minus under root of b square minus 4ac by 2. Okay? So let us take this one as alpha and let us take this one as beta. Right? Now, we have two roots, alpha and beta. Let us find the sum of the roots, alpha plus beta. So alpha is when you add these terms, there is a plus under root of b square minus 4ac and there is a minus of under root b square minus 4ac. They are going to get cancelled. So sum of the roots is going to be twice of minus b by 2, that is minus b by a. Right? When you multiply this, the two roots, alpha into beta, when you multiply these terms, I just tell you simply, it is going to come out to be c by a, that is the constant term upon the leading coefficient a. यहाँ पे sum of the roots is going to be the negative coefficient of b divided by a. Okay? These two terms you need to remember. This is the sum of the roots and this is the product of the roots. Right? Now, this expression, this b square minus 4ac, it is quite a unique expression. We are going to name this as another term, that is d, where d is the discriminant. Right? So this d discriminant is your b square minus 4ac. For any quadratic equation, you can find the discriminant. Now, we have written this formula under root of b square minus 4ac. Now, for any case, can you assume that can this term be negative? No, because this is inside of under root. If you take this as b square minus 4ac, if it comes out to be negative, then your root will not be defined. For example, if it comes out to be minus 3, it will not be defined, it will not be a real number. Then you will go in the imaginary numbers, or you can call them complex numbers. You go in that category. Okay? So we have certain number of cases in this. Okay? First one, when your d is greater than 0, when your discriminant in any quadratic equation is greater than 0, that is b square minus 4ac is greater than 0, in that case you will have for that quadratic equation two real and distinct roots. Understood this? Second case, when your discriminant is equal to 0, in that case you will have two equal roots. Both of the roots are going to be equal. Okay. Sometimes J uses the term repetitive roots or coincident roots. These are just mind tricks to try to confuse you. I am telling you this in advance so that in any equation, coincident roots, if there is coincident roots, you don't need to be confused. It basically means there are going to be two equal roots, two or more number of equal roots. Coincident roots means equal roots. Fine. there are going to be two equal roots. And the third case is where d is less than 0. So in this case, we are going to have two imaginary roots. Since when discriminant is less than 0, if under root के अंदर अगर negative आएगा, then there is going to be imaginary root. It's fine. We are not going to the complex numbers thing for now. So just understood this. I hope you understood this. Fine. You can always say two complex roots as well for this expression. And these two complex roots will always exist in a right term conjugate pair. What I mean by this is, I hope you are aware of complex numbers a little bit, just a little bit, where under root of -1 is equal to iota. Fine. So if we have an equation where we have minus b plus minus under root of, let's say, minus 3 upon 2. Fine. So the roots are going to be minus b plus minus 3 by 2a, and second root is going to be minus b minus under root of 3 divided by 2a. Now we have a plus term over here and minus term over here. So these things, where one is a plus term and another is a minus term, this is known as a conjugate pair, as written over there. So this is what I talk about when I say conjugate pairs. Okay. So you can write this under root of minus 3 as 3 times of iota. Fine. So your expression becomes minus b plus 3i upon 2a. This I is not a variable, it is your iota whose value is equal to under root of minus 1. Fine. Minus b plus 3i upon 2a and minus b minus 3i upon 2a. So the roots are going to exist in there. Let's say, for example, you have 2 plus 5i as one root of this equation. So if I of any quadratic equation, so if I tell you to find the second root of this quadratic equation, what is going to be? It is going to be 2 minus 5i. Since one root exists like this, the other will be the conjugate pair of this, that is 2 minus 5i. Let's say if I tell you 5 minus 7i, what is going to be the quadratic minus 5 minus 7i? What is going to be the second root of this equation? It is going to be minus 5 plus 7i. This. I hope you understood this basic terms. Fine. I'll remove this. Now the last thing I'll tell you for today is difference of the roots, alpha minus beta. I'll just tell you the formula for this. Modulus of alpha minus beta, since when I wrote this equation ax square plus bx plus c is equal to 0, which has two roots, alpha and beta. And both of the roots are minus b plus minus under root, and write directly as d by 2a. I do not know if alpha is greater or beta is greater. So when I find the difference of the roots, I am going to take modulus. So the modulus will turn out to be modulus of root d by 2a. Fine. So this is the difference of the roots. That's it for today in this class. We'll teach further in the next one. I hope you like this session. Thanks a lot. Bye.